Welcome back. The last thing that we're going to look at in our foray into stoichiometry this time is looking at percentage yield. So let's get started. Generally, what we're talking about is when we're working out a percentage yield, we're working out how much of the product we got compared to what we expected to do. Okay, so we work this out in the same way that we work out any percentage. If you think about when you work out the percentage on a test, you take the number of marks that you got divided by the maximum number of marks that were available and multiply by 100. We do the same for yield. So what's happening is reactions rarely go to completion. That is, we rarely use 100% of the reactants that we put in to go all the way to the products. So sometimes they don't all make the expected product. Sometimes they've made a byproduct. Something else has been made along the way, or the reaction just doesn't go in 100% due to a number of different factors. When this happens, we can calculate the percentage yield, or how much was yielded of the reaction compared to what was expected. Okay, so we calculate the percentage yield of the reaction, which is simply the percentage of the maximum yield that was obtained. Okay, so when we look at maximum yield, we're going to be talking about the amount predicted by stoichiometry. Okay, all those calculations that we've been doing so far, that's what we're talking about when we talk about the theoretical or the maximum yield. When we do these questions, you'll always be given the mass of the product that was obtained from the reaction, or the number of mole that was obtained from the reaction. Okay, so then you use stoichiometry to calculate the expected mass that you would have hoped to get, and then do your calculation working out the percentage yield, taking the mass obtained divided by the mass expected and multiplying by 100. You can also do these calculations with mole, but typically you'll be given the mass. So if you're using mass, I would stick to mass. Let's have a look at a quick example. So just one example for this one. So we're looking at percentage yield, and this is the kind of question that you would see. We're told that potassium chlorate decomposes on slight heating in the presence of a catalyst according to this reaction. So we have 2 potassium chlorate going to potassium chloride and 3 oxygen gas being given off. We're informed that a certain experiment has 40 grams of potassium chlorate. This is heated until it completely decomposes, so there's nothing left over. What is the theoretical yield of oxygen gas? So this is asking us to work out the maximum that we could hope to achieve. Okay, so what is the maximum we could hope to see? And we're going to use stoichiometry to do that. So the first thing that we're going to do is work out the amount of potassium chlorate that we started with in mole. So we're going to take the 40 grams and we're going to divide by the molar mass of potassium chlorate, which is going to be 39.1 plus 35.5 plus our 3 times oxygen, which is 16, which gives us a total of 0.326 mole of potassium chlorate being heated. Okay, so now to work out our expected yield, we're going to find the mole ratio between the oxygen and the chlorate. So I want to write the number of mole of oxygen in terms of a ratio to the number of mole of potassium chlorate. So what I want is 3, what I've got is 2 multiplied by potassium chlorate, which is going to be 3 over 2 times 0.326 mole, which is going to give us a total of 0.489 mole of oxygen. That's the maximum amount of oxygen that we could hope to get. So let's convert that to a mass. 0.489 times 32, because we're looking at oxygen gas, so O2, which is going to give us 15.66 grams. So that's our mass of oxygen. So if I want to work out the percentage yield, I'm going to take the fact that they told me it this experiment actually only produced 14.9 grams. Okay, so this is the mass obtained. And the maximum mass that we could expect is 15.66. So our percentage yield is going to equal what we actually got divided by the maximum possible, multiplied by 100/1, and that is going to give us 95.5%. So this reaction went in a 95.5% yield, and that's how we calculate percentage yield. Okay, I'll see you in class.